Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. So we're going to the part 2 of finding the area of a curve entirely below the x-axis. In the part 1, I introduced the rules, I introduced the concept, and I solved an example. But in this case now, I'm going to solve one more example, and we'll call it a day for this video, all right? So like I said, the area of a curve entirely below the x-axis will be negative because it's below the x-axis. But you have to ignore the negative sign because an area will always be what? Positive. Because the area is going to always be what? Positive. So before I proceed, please don't forget to like, share, and subscribe. And if you have any question, please don't hesitate to contact me. And also, don't forget to click the notification bell so that when I post new videos, you'll be the first person to know. All right, so let's pick this example. Okay, so let's say we have this. What is the area between the curve y is equal to x squared minus 4, all right? And the x-axis. Okay? And we're told to find the area for this. So how do we go about it? So x squared minus 4, so if you sketch the graph for this, it should look like this. X squared, so it's going to be a translation by 4 units in the y direction. So it's going to be this. So here is going to be minus 4, all right? So that means we're finding the area bounded by this curve. So we're finding the area covered by this. Okay, so we're looking for the area covered by this part here. Okay, so that means in order for us to find the area, we need to know what the upper limit is and the lower limit. So we need to know this point here, the upper limit and the lower limit. Are you seeing it? So, and because we can see that the curve is crossing the x-axis, that means when at x-intercepts, so remember in quadratic equation, I told you that at x-intercepts, all right, at x-intercepts, y will be equal to what? 0. So that means as x-intercepts, that at those points, x squared minus 4 will be equal to what? 0. So now this looks like a quadratic equation now, all right? So how do you find it? So this is going to call this is what we're going to call the roots of the quadratic equation. So there are several methods I taught you in that series on how to solve quadratic equation. You can use difference of two. No, here you can use difference of 2 squared can work here. You can use the quadratic formula. You can also use maybe when a is equal to 1 method here. So anyone can work here. So because I can also break this down, so I'm going to solve with 2 methods. All right, just to make it interesting. So x squared minus 4 is the same thing as x squared minus 2 squared. Are you seeing it? And remember, this is difference of 2 squares. So I said when the difference of 2 squares, I told you when a squared minus b squared is going to be equal to a minus b, a plus b, right? So that means it's going to give us x minus 2 and what? X plus 2. These are equal to what? 0. Then because they're equal to 0, so it will be x minus 2 will be equal to 0, or x plus 2 will be equal to 0. So x will be equal to 2 or minus 2. Are you seeing it? So this is using the difference of 2 square method. Also, you can decide to use just straight simplification. All right, so or you can use quadratic formula. Anyone you want to use, you can use. So we have x squared minus. So we have this. Clean this a bit. So we have we have x squared minus 4 is equal to 0. I take 4 to the other side. So x squared is going to be equal to 4. To remove this square, I take the square root of both sides. I take the square root of both sides. And this will cancel this. And the square root of 4, x will be equal to plus or minus 2. So I told you in quadratic equation, when you're solving square root is plus or minus. So therefore, x will be equal to plus 2 or x will be equal to minus 2. So you can see it's exactly the same thing. Or you can use any method you want, you should get the same result. So that means for this question now, our A now is going to be equal to 2 because it has to be on the positive side. And our B now is going to be equal to minus 2. So that means in order to solve this, we need to then integrate between what? 2 and minus 2. Okay? We need to then integrate between 2 and minus 2. So step 2, so step 1, we found step 1, we know that it must be positive. Okay? The area will be negative, all right, because it's below the x-axis, but you ignore the negative sign. So the area will be negative, but you have to what? But you will ignore the negative sign. Okay? So step 2, I told you then you have to integrate y between the upper limit, which you found to be 2, and the lower limit, which is minus 2. And the y was x squared, I believe, minus 4. Okay? So the y was x squared minus 4 between 2 and what? Negative 2. So that will give you, you add 1 to the power divided by the new power, so it'll be x. 2 plus 1 will give you 3 divided by 3 minus. When you integrate a constant, it's going to give us 4x between 2 and minus 2. Now, the next part I told you was that step 3, we then substitute the upper limit. The upper limit is what? 2. So anywhere you see x, you're going to put 2. So that's going to give us 2 cubed divided by 3 minus 4, 2. Okay? And this is going to give us minus 16 over 3. Then step 4. Okay? Step 4, we now substitute the lower limit. The lower limit is minus 2. So it's going to be minus 2 cubed divided by 3 minus 4 into bracket minus 2. And when you do that, it should give you 16 over what? Over 3. Are you seeing it? So step 5 is going to be the result from the upper limit minus the result from the what? Lower limit. So step 5 is going to become minus 16 divided by 3 minus 16 over 3. And this is going to give us minus 32 divided by what? 3. So like I said, you have to ignore the negative sign. So that means this is going to give us what? 32 over 3 units what? Squared. All right? So that's how you do it. So that's how you find the area under the curve when it's below the x-axis. So in this case here, we needed to find the upper and the lower limit, and we used quadratic equation to do that. Then after we did that, we now integrated as normal. We substituted the upper limit, then we substituted the lower limit, and we subtracted it, and that gave us what? The area. All right. All right, that is that for that. So the next video I'm going to talk about now will be the area under a curve, where we have a combination of both above and below. In this video, we talked about below. In the previous video, we talked about above. What about if we have questions that have the combination of both above and below? How do you solve that? All right, so that's what we're going to talk about in the next video. So it's very important that you subscribe so that when I post the next video, you'll be the first person to know. All right, so see you soon. I'll see you soon.